Good morning, class. This is your teacher, Jofi, welcoming you to our YouTube classroom. If you haven't subscribed to this channel, please subscribe now and also click the notification bell so you will be notified when a new video is uploaded. Our topic today is representing real-life situations using rational functions. Let us start by defining a rational function. A rational function, denoted by r of x, is a function of the form r of x equals p of x over q of x, where p of x and q of x are polynomial functions, and q of x here is not equal to 0. Notice, guys, that this whole thing is a fraction. Because when we say rational, it is actually a fraction. So when we have a rational function, it is a function in the form of a fraction. So we have here p of x, the numerator, and q of x, the denominator. And q of x is not equal to 0. Do you remember, guys, why q of x should not be equal to 0? Yes, that's correct. So if we have 0 in the q of x, that gives you a 0 denominator. And if we have a 0 denominator, the fraction becomes undefined. That is why in the domain of r of x is a set of real numbers such that q of x is not equal to 0. That means we remove the values of x for which q of x will become 0. Let us look at some examples of rational functions. So number 1, we have r of x is equal to x cubed minus 1 all over x plus 1. Notice here that we have a restriction that x should not be equal to negative 1. Both numerator and denominator are polynomials. The denominator, which is x plus 1, has restriction because it should not be equal to 0. Let's look at example number 2. f of x is equal to 1 over x. X is not equal to 0. The numerator is a polynomial function with degree 0. So we're talking about 1 here. This is a constant function and the degree is 0. The denominator, this one is x, is a polynomial function and it must not be equal to 0. Now let's look at real-life situations modeled by rational functions. Let's look at this first situation. The local government unit, or LGU, allotted a budget of 100,000 pesos for the daycare center. The amount shall be divided equally to all the pupils in the daycare center. Write an equation f of x showing the relationship of the allotted amount per pupil, the total number of children represented by x. We may present this in a table. So let's look at the table, identifying the number of children as the x and the allocation amount per child f of x. Okay. Let us try this. If there are 10 children or pupils in the daycare center and we had a budget of 100,000 pesos, what should be f of x? Remember that the amount 100,000 shall be divided equally to all the pupils in the daycare. Therefore, we have 100,000 divided by 10 for our f of x. Therefore, you have 10,000 pesos. What if we have 20 students? There you go. So you have 100,000 divided by 20. There you have 5,000 pesos for each student. And what if there are more students that come, or children in the daycare who come and join classes? We have 50 pupils. So you have 100,000 divided by 50. You have 2,000. And then if we have 100 pupils, yes, you have 1,000. And if we have 200 pupils in the daycare, then each pupil will have 500 pesos. Okay, remember that we're looking for the equation f of x, showing the relationship. Looking at the table, okay, what we did was we divided, right? So to solve or to get the value of f of x, we divided the amount 100,000 by the value of x. Therefore, the rational function representing this situation is f of x is equal to 100,000 divided by x. Or we say f of x equals 100,000 over x. Here is situation number 2. Suppose a benefactor wants to supplement the budget allotted for each child by donating additional 650 per child. If h of x represents the new amount allotted per child, construct a function representing the relationship. So this is actually a continuation of situation number 1. Suppose there's a benefactor or a philanthropist who wants to add 650 pesos for each child. We are going to compute or to find out the function h of x that represents the new relationship when the benefactor will be giving 650 pesos per child. So again, let us revise the table that we have in number 1. Okay, so we have the number of children represented by x, and now the new allocated amount per child, we name it as h of x. Okay, so remember, first we started with 10 children. Okay, so we had 100 divided by 10, that was 100,000 divided by 10, that was 10,000. And now we have additional 650, therefore we have 10,000 plus 650. Next, we had 20, 100,000 divided by 20, that was 5,000 plus 650. So you have there 5,000 plus 650. Okay, then we have 50, 2,000 plus 650, and then 100, you have 1,000 plus 650. And lastly, you have when the number of children is 200, the amount is 500 plus 650. Therefore, the rational function representing this situation is just similar to the previous item in number 1 plus the 650. Therefore, we have h of x is equal to 100,000 over x plus 650. Okay? The third example, we have a car that is to travel a distance of 70 kilometers. We are to express the velocity v as a function of time t in hours. Let us try to present this in a table again. So we have time in hours given by t and velocity kilometer per hour. And this is represented by v of t. Okay? So remember that we have 70 kilometers to travel. If we have 1 hour to travel that 70 kilometers, what should be your velocity? So you will be arriving at that distance. So you only have 1 hour, therefore you should travel at, yes, correct, 70 kilometers per hour. So your answer there should be 70. Okay, if we have 2 hours, so you have 2 hours to travel 70 kilometers. So you have 70 divided by 2 hours, so you have 35. Therefore, your velocity there should be 35 km per hour. Okay, if we have 5 hours to travel, maybe you can relax a little bit. Okay, so you have 70 divided by 5 hours, so you have 14 km per hour. And this one may be very slow travel. And one more try, if we have 10 hours to travel, oh no, they're very long hours to travel. So you have 70 divided by 10. Therefore, you have 7 km per hour. Or maybe that's a lot of traffic. And now you have the rational function representing this situation. We have v of t. v of t is equal to 70 divided by t. So that's it for today's lesson regarding representations of functions in rational form. Please do your homework as given or assigned in your weekly home learning plan. So God bless you guys and have a great day. Enjoy learning!